Good morning. We have an exciting one for you today.
Hi, even though you can't see me.
We started this 12-day event 12 days ago with the launch of O1, our first reasoning model. It's been amazing to see what people are doing with that and very gratifying to hear how much people like it. We view this as sort of the beginning of the next phase of AI, where you can use these models to do increasingly complex tasks that require a lot of reasoning. And so for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica and in the grand tradition of OpenAI being really, truly.
So I didn't understand the last part when he said Telefonica. I tried to check that.
Fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to we're going to bad at name, but out of respect to our friends at Telefonica and in the grand tradition.
Yeah, friends at Telefonica. I don't know, the subtitles don't show that clearly and I don't understand. And as far as the naming goes, this is a clear indication that OpenAI follows the footsteps of Microsoft, just as Windows 8 skipped Windows 9 and jumped to 10 and said this would be the last Windows they would ever supply. They still launched Windows 11. So based on that, we can expect OpenAI to not keep their words. But okay, let's continue.
Of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to we're going to announce two models today, O3 and o3-mini. O3 is a very, very smart model. O3-mini is an incredibly smart model, but really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. The good news is we're going to make them available for public safety testing starting today. You can apply and we'll talk about that later. We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access for researchers that want to help us test.
So let us see the website, which is about application for that testing part. Wow, within a day of its launch, it already has a Wikipedia page. Okay. So I'm trying to find the page where we can apply for the safety part. I'm sure I'll not be selected, but as they said, they didn't. As they've said, they didn't. They don't expect. I mean, they don't restrict anyone from application. Anyone can apply. So I'll try my chance. And where do I apply? Safety, I guess it has to be. How do I apply? OpenAI O3 safety testing website link. I think they've given it somewhere here. Oh, I mean,
Good morning. We have an exciting one for you today. We started this 12-day event
high test time compute settings, we're able to achieve.
to talk about it.
Cool. Thank you so much, Sam. So my name is Mark. I lead research at
We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access for researchers that want to help us test. We'll talk more at the end about when these models, when we expect to make these models generally available. But we're so excited to show you what they can do, to talk about their performance. Got a little surprise. We'll show you some demos. And without further ado, I'll hand it over to Mark to talk about it.
anyway, so I don't know where the link is. Let's proceed. Let's close this.
We'll talk more at the end about when these models,
hard technical benchmarks with O3's capabilities. Sam. So my name is Mark. I lead research at OpenAI, and I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SweBench verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really...
I've actually seen the whole video. Since this is a reactions video, I'll skip through the redundant parts. You can see the visualizations, the numbers and the graphs, so I'll skip that. You can understand those percentages, like differences.
O1 achieves an ELO on this contest coding site called Codeforce is about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2,500.
That's tough.
Well, I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
Gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there.
Let's see the numbers again. 27.
500.
That's tough. Gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there. Great.
This model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So
very strong scores. So competition math AIME 2024. Usually we see these benchmarks and we don't actually, usually people don't show the exact questions. So let's see some of those questions. AIME competition math. AIME competition math 2024. Every morning Aya goes, is the problem. I wish I could see just the question, without the answer. So how do I see the entire test? Yeah. Every morning Aya goes for a 9-kilometer long walk and stops at a coffee shop afterwards. I'm rereading it. She walks at a constant speed of s kilometers per hour. The walk takes 4 hours, including 10 minutes spent in the coffee shop. When she walks at s plus 2 kilometers per hour, the walk takes 2 hours and 24 minutes, including 10 minutes spent in the coffee shop. Suppose Aya walks at s plus half kilometers per hour. Find the number of minutes the walk takes her, including the 10 minutes spent in the coffee shop. So we have the distance constant and the time spent at the coffee shop constant. So we'll use that. So s equal to 9 by 4 minus t, and similarly you will form other equations. 9 by 4 minus t is s, then s plus 2 is 9 by 4 minus t by s plus 2. I think we'll have 3 equations and 2 variables, so we'll get the answer. Do you want me to solve this? Yeah, it's a basic question I can solve, so no, it's not a bad idea, I guess. How do I write it? I have a RAM problem, so I won't launch cursor. I'll type it here. I'll type somewhere some text. This one will be easy on RAM, I guess. Just a text editor. One question is 9 equal to s equal to 9 by 4 minus t by 60, as t is in minutes and 4 is in hours and s is in kilometers per hour. We are converting it into hours. So we have to include this in the brackets. First equation. The second equation is what is the second equation? When she walks at s plus 2 kilometers per hour, the walk takes her 2 hours and 24 minutes. Okay, plus t. So 9 by s plus 2. This thing. Nine by s plus 2 equal to, what is this? 2 hours and 24 minutes. So that is 24 by 60 is 4. So 2.4 hours. So Now my doubt is the walk takes 2 hours and 24 minutes including t minutes. So this walk includes t minutes. So this is 2.4 hours. Not 2.4 plus t by 60, because this includes everything, all the total time. The walk takes, including for them to mean that we need to add, for us to add 2 hours, 2.4 hours plus t, the question should have said in addition to t minutes, in addition. Okay, since it already includes, we don't need to include that. I guess most of you, this could be confusing for some. It was confusing for me. Suppose I walks at s plus half. Now the distance is constant. So we'll do this again. 9 by s plus 0.5 equal to okay, we need to find that. Okay, I think the walk takes her 24 minutes. I think we must add t minutes because the walk takes her 2 hours and 24 minutes and t is in addition. So I'm sorry again. So I guess it's better to add t because it's just for the walk and t is for the time spent at the coffee shop. And in this case, we need to find times. We need to find, this is what we need to find. Okay, so we have two equations and two unsolved. So we need to rearrange that and we get s into 4 minus t by 60 equal to 9 and okay, s plus 2 equal to s plus 2 into 2.4 plus t by 60 equal to 9. Equal to 9. So we need to multiply that 4s minus ts by 60. So since both are equal, we can equate these and write 4s minus ts by 60 equal to 2.4s plus st by 60. The speed has increased. Okay, time must decrease. Time must have decreased. It was earlier 4 minus t by 60, so 2.4. It must be lower. Yeah. 2.4s plus st by 60. 2.4s plus st by 60 plus 4.8 plus 4.8 plus t by 30. Now we can cancel. We can't cancel ts by 60 on both sides. We need to add them. 1.6 s 1.6 s equal to ts by 30 STTS ST by 30 plus 4.8 plus T by 30. From this equation we can have 4s minus st by 60 equal to 9. So st by 60 equal to 4s minus 9. We'll use that and use it here. So 1.6s equal to, doing it on paper will be much easier. 1.6s equal to st by 30 is 2 times st by 60, so 8s minus 18 plus 4.8 plus t by 30, 8 plus t by 30. Now we'll rearrange the terms again. I guess I'm not doing anything wrong. I hope I'm not doing anything wrong. We get 18 on this side, 18 equal to 6. I fear that I might get something that's not so useful. I mean, like what if we get the same equations again? So essentially we get nothing. 4.8 plus t by 30, and it would be very funny. I mean, all my efforts. Okay, 13.2 equal to 6.4s plus t by 30. So we'll multiply it by 30 on both sides. 39.6 396 equal to 6.4 into 10, 64 into 3, 192s plus t. That is the first equation. That is a simpler equation. And now we'll try to get the st part out of this. Yeah. I think we can get s from this and substitute the whole thing in this final one. Yeah, and we can have an equation totally in t. So s equal to 396 minus t divided by 192, and we'll take that and substitute it in the above equation. So we get this 396 minus t home star t by 192 by 60. 60 into 192 will take it to the other side. 4 into 4 into 1, yeah, 4. So 4 into this 4s, right? So we'll take that. 4 4 is 16, 4 48. So 396 minus t by 48 minus 9. The whole thing we need to multiply by 6. Should we multiply or should we keep it as it is? Let's keep it as it is. Divided by 60 divided by 192. So the 60 here and the 192 here. Earlier I hadn't typed it there, now I have typed it. Now how do I simplify my efforts is the question. I don't see a way. Uh, 396 minus t. I think I'll put the whole equation and solve for t. I'll put the whole equation in Wolfram alpha and hopefully it will give me the values of t. It seems I have made a severe mistake somewhere. Let us paste all these equations and ask for it to solve again. I'm thinking about how I can get it to solve a set of equations. Okay. I guess this is how you enter two equations into Wolfram alpha and it solves for both. It has given S as this and it has two solutions. So 3049, under root of 3049, is it less than 53 or more than 53? So 50/50s are 2500. So I think since the equations are wrong, so because time can't be negative, it's like one is negative, the other is positive. We need both of them to be positive. So I guess it actually doesn't include. So let's try this, change that. We get negative time, it seems. When 9 by s plus 2, 9 kilometers per hour, 9 by s plus 2 is hours, 24 minutes, it is 2.4. So 2.4 includes t. Now the first equation, constant speed is 9 kilometers. Okay, the walk takes 4 minutes including. It seems it is slightly difficult, so we need to try harder, I guess. Yeah, goes. I'm trying to reread the question. 9 kilometers long walk and stops at a coffee shop afterwards. So how I'm seeing this is there's a 9 kilometer long walk and the coffee shop is here. I mean, is it at the like? Oh. She takes 9 hours to travel this 9. She takes these are 2 points. I don't know what these two. Let's call them A and B. So she takes 4 hours to reach from here to here and drink coffee. So the T includes that. When she walks at s plus 2, suppose The including t part, I mean, it's hard. The problem is the question is confusing. How to include t? Should I include t or should I exclude t is the question. Because here I excluded t. Okay, here also I must exclude t. 2.4 minus t. Earlier I did exclude t. Okay, at least in this case we got to, if t is this, s is this, we need to calculate this. We'll ask it to calculate this. Equal to question mark. Let us remove this and try. I mean, it could understand the earlier parts, but it doesn't understand this one. I guess I'm missing tabs. I guess I'll get it now. Yeah, we got this. Anyway, so let's see the approximate forms. So in this case we get all positive. Let us verify if our answers are correct. Let's see the solution. So our formulation was slightly different. 9 by, like, let's see here, it's better. S equal to like 9 by S. Yeah, 9 by S equal to, ours was 9 by S equal to 4 minus T. Like 9, if you take this S here and like we've converted T into R's, they didn't do that. Okay, we forgot to convert T here. Oh my god, that's where the mistake comes. Okay, now we'll get the right answer. Yeah, so anyway, what is the solution? 204 minutes. What do we get? We get y equal to 27. 27 is in hours. No, we must calculate this. Yeah, 17 by 5, that is 3.4, and here it is 3.4. So we get our answer correct. Wow, what a, I mean, I made some mistakes in converting the numbers, and finally, so we at least learned how to use Wolfram Alpha, like how to enter multiple equations and get the answer. Luckily, we somehow figured out that using flower brackets we can get this. This is my first video, so please forgive me for all my unlikable elements and unlikable elements of the video as well. So let us continue with the video.
O3 gets about 96.7%.
So that is one question of competition math. While the challenge is in the challenging part is framing the equations, but once you frame the equations, if you take care of the conversions and if you have access to Wolfram Alpha, it's easy. But since the students don't have access to that, it's difficult for them. Let's try the second one. There exist real numbers x and y both greater than 1 such that log x yx find xy. I guess if we paste the whole thing in Wolfram Alpha, we'll get the answer. Okay, but let us think. Let us try to make at least some effort. Yeah, let's put in some effort. For log, I'll use L. Underscore x is the subscript. X, and you will understand the superscript part. Yeah, this is why. Okay. So what can we do? I mean, this doesn't look good enough. So I can ask ChatGPT to solve, but I mean, we're competing with ChatGPT as human beings. So let me try. I mean, I'm trying this to prove that this statistic doesn't mean that it is extremely good at maths. I mean, even if it scores 100%, we shouldn't be scared, because the competition math itself isn't that difficult. I mean, we'll use this Wolfram Alpha after we frame the equations, because Wolfram Alpha was created by human beings totally, so we can rely on human beings, and the creators understand it totally. There is no black box, like what happens that they are clear about. So it's not like ChatGPT. Also, I don't know what people mean when they say I don't understand how ChatGPT works. Usually it's easier for people to understand what the question, like what they mean, if they say what question they don't have an answer to. For example, so let me, for example, let's take this laptop. I don't understand how this laptop works. So what do I mean by that? So when I press a keystroke, I know that there is a CPU. There are a lot of transistors on that, but how does, like, those transistors are like logic gates, right? I only know it on a higher level. Those logic gates, like and or types, somehow convert. We type something, and when you ask it to compute something, the operating system or some other software converts it into a solution, like converts it into a format that logic gates can process. How does that happen? Now this is a more concrete question. So when I say I don't understand how computers work, now you understand what I mean. But when ChatGPT, when people who work on large language models say they don't understand it, I mean, what do they mean? I know that once they train the model, there is an there are weights, and if someone gets the weights, he can't look at the weights and take the input and give the output that ChatGPT would give. Yeah. So is that what you mean? Like how the weights help the LLM transform input into output, or what? Similarly, in case of quantum mechanics, people say we don't understand quantum mechanics. Like there was a video by Royal Institute. In that, physicist says what exactly they mean. I don't remember that, but only one person has said that what exactly they mean when they say they don't understand. So I mean, at least only one person said it on video. It's better if people speak. Now let's continue. Let's solve another problem. Let me check how long this video has become. I can't see. I can't see how long the video is. Okay, let's continue. Log x. So like the exponent comes out, so we can say that is x log of y equal to 4y log of x. Yeah. X log y equal to 4 log x. X log y equal to 4 log x. I think we can equate it to some p. O equal to 10. Okay. So y power x, I ignored this part. So y power x equal to x power 10. X power 4y equal to y power 10. Okay, we can simplify this now. I did not see this 10, but anyway. Y power x equal to x power 10. And x to the power 4y equal to y to the power 10. What we need is xy. We need xy equal to. Let's put these three equations in Wolfram alpha and make our efforts simplify our efforts. Let's put it. So here I just hit Ctrl C. So because I am on Kate, if I hit Ctrl C, it automatically copies the whole thing. I am on Kate is on Debian. Like this is Debian. I use Debian because it's more stable than KDE. And my 8 GB RAM 11 Gen i5 doesn't seem to be comfortable with Windows 11. I mean, it slows down. Frankly, when I open Firefox, oh my god. What is happening? Okay. X, Y, let us hit Z, we'll find the answer. Okay. Z is 1, but it says X. There exist real numbers X and Y both greater than 1 such that, okay, both are greater than 1, but here, okay, let's include another thing. X greater than 1, Y greater than 1. X greater than 1, Y greater than 1. I don't know how to include conditions. X to the power 1 equal to y power 10, y power x equal to x power 10, and it says xy equal to 1. My god. X greater than 1, y greater than 1. The brackets change for some reason, and it doesn't understand that. Let me include natural language then. Both x and y are greater than 1. Check your spelling. Avoid mixing. Okay, how else can I include the condition? Let us verify if so. Is it giving only these solutions? Both greater than 1. I'm trying it on my notebook because it's easier. I power x equal to x power 10. X power 4y equal to y power 10. Xy equal to question mark, x greater than 1, y greater than 1. A to the power log a equal to x. X equal to a power y. Y equal to log x to the base a. So x equal to a to the power log x to the base a. This will be the last problem I'll try, and I'll say that these questions are difficult. So it's something. ChatGPT is able to do that, so it's definitely better, I guess. At least better than me. So if you are a company, you would do better hiring ChatGPT than me. Wow, it's so disheartening that I stand nowhere in the job market if I have to compete against ChatGPT. we get xy equal to 25. Oh my god, it's actually simple. I don't know why Wolfram Alpha couldn't get this, but see, y power x equal to x power 10, x power 4y equal to y power 10. I'll show this here. Yeah, y power x equal to x power 10, x power 4y equal to y power 10, xy equal to, actually we need to find that. What we actually do is we apply log to both sides. When we apply log, so like log, let's, L is for log, we just need to L, we'll get x L y equal to 10lx, 10lx, and we do the same to the second one. This is the first one, this is the second one. We'll get 4y lx, 4y lx equal to 10 ly. Now we multiply these. If we multiply the first, and the second, we'll get 4xy ly lx equal to 100 ly lx. We'll cancel, so we'll get 4xy lx ly equal to 100 lx ly. Now lx ly cancel on both sides, we get 4xy equal to 100, xy equal to 25. I mean, I don't know why Wolfram Alpha couldn't solve this. This was very easy. I mean, once you put it on paper. So I put this on paper. This is how I did it. Yeah. Anyway, at least the second question wasn't as difficult. I mean, once I put it on paper, it was much easier. Alice and Bob play the following game. A stack of n tokens lies before them. Of n tokens lies before them. The players take turns with Alice going first on each turn. The player removes one token or 4 tokens from the stack. The player who removes the last token wins. A stack of n tokens lies before them. The player takes turn with going first on each turn. The player removes one token or 4 tokens from the stack. The player who removes the last token wins. Find the number of positive integers n less than or equal to 2024, such that there is a strategy that guarantees that Bob wins regardless of Alice's moves. So a player can take one token or 4 tokens from the stack. Actually, this question, I'm familiar with this kind of question because of this video. The power of algorithms. Not this. Algorithms in daily life. I had seen a video long ago that covered this. I don't remember the name. The power of algorithms. Algorithm. So where is that video? The secret rules of modern living. In this video,
without us noticing, modern life has been taken over. As we search for love, shop online, travel the world, even as we save lives, there are step-by-step instructions working quietly behind the scenes.
I'm searching for that instant where he describes a similar
They're
game.
called algorithms.
It's not here.
Algorithms are everywhere.
Search again.
These bite-sized chunks of maths,
here it is.
smartphones and the internet.
So the game.
There is a pattern behind all no matter what them.
How's it first? Okay.
So off you go. We tend to associate algorithms with computers, smartphones and the internet. Professed, here we're playing a mathematical game with a jar full of chocolates and one red hot chili. The aim is not to be left with the chili at the end. But what these students don't know is that I'm playing it with the help of an algorithm.
Okay. You ready? Okay, I'm going to go first. So remember, you can take 1, 2 or 3 chocolates at a time. So I'm not a greedy guy, so I'll just take 1. Now, your turn.
Each player takes on their turn between 1 and 3 chocolates.
So you've taken 2, okay. So I'll take 2.
Whatever my opponent does, my algorithm tells me how to respond.
Okay.
Yeah. So I know this question, like it's similar. There, like so in this case, the person who removes the last tokens wins. In that case, last but one token wins. So it's the same question. Like in that case, you remove all the chocolates, but you'll be left with the. Even in that case, we'll remove chocolates. Yeah. Here we remove tokens. There we remove chocolates. Yeah. Whoever removes the chocolates wins. So the question is same. Anyway, this question seems tough, so I won't try to solve it because the video must have gotten long already. Let me continue with that.
Accuracy.
Okay, we'll see this PhD level GPQA diamond questions. Yeah, I'll probably not be able to solve it. I won't be able to solve it. I'll just see GPQA PhD level. PhD. Science questions. Oh my god. PhD level science questions GPQA. Let me close the videos. Discard. That's to the right. I'll close this window. Close this. I don't need this. Expert. Let's see this. Okay, GPQA means Google Proof Question and Answer Benchmark. I didn't know that earlier. Okay. I mean, Google Proof meaning you won't be able to search the answers, I guess. So it's not just Google Proof, it's DuckDuckGo Proof, Bing proof. So, yeah. Okay. Maybe Perplexity AI proof. We present GPQA, a challenging dataset of 448 multiple choice questions. Where will I find these questions? Unrestricted access to the unrestricted access. The questions are also difficult for this for state-of-the-art AI systems, which are okay. But where are the questions? The collection of external contractors of work to write and validate the dataset required. They have computer or currently indicate that they are proficient or fluent in English. Okay. This PhD people write the questions. We solicit difficult questions from domain experts in subdomains. Okay. Shows and the process consists of 4 main stages, and we hire 61 contractors. Okay, 61 people. I guess these 61 people give those questions. Okay. Methyl cyclo something was allowed to react with something and a catalytic amount of something, a bright yellow something. How many chemically distinct isomers make up the final product? Okay. I mean, this question, it's like a chemical reaction you'll get. Okay. Exists as an interconverting mixture of 3 isomers. If there are 4 dienes and 4 different directions of approach, the dienophile can take. There are 416 products. Okay. So the answer is B. Expert validator. Okay, this one question. Raise the question. There's an expert validator. Okay. And one person, you get the questions. Okay. Expert validator number 1, expert validator number 2. They get the same question. Testing. Okay. Okay. Before the explanation, part 1. Okay. First is I think the flow is like this. Some people give the questions, some other people, experts, both are one set gives the questions, one set of people gives the questions, another set of people validate it. So for each question there are two validators. They answer the question themselves and then see the answer, see the explanation, and then whether they agree or not. Then there is a non-expert also. Wow. In order to ensure that this question is difficult, they pick those questions which have correct answers because of the expert validators, but non-experts must answer it wrong. So only if if more than one person out of three expert non-expert validators answer the question correctly, that question will be rejected. Wow. I mean, okay. So this is how GPQA questions are formed. It's like you want to torture ordinary people. I mean, it's like you don't want to appreciate them. Okay, let's continue. Like these are some GPQA questions, I guess. Anyway, we've come to see, we are here to see some of the questions. So one question we have seen. Let us see some more questions. Yeah, this is an astrophysics question. Astronomers are studying a star with a TEF, temperature effective. They are interested in spectroscopically determined surface gravity of the star. Wow. It's possible to spectroscopically determine the surface gravity of the star. Like, so if you look at the light, you can say you can predict the gravity. I guess it's because the higher the mass, the spectrum is shifted towards that. I mean, higher frequency of lights. So based on that, because mass, fuel consumption, like the fusion, you need fuel. So higher the mass, higher the fusion, higher the frequency of light. So, and mass also determines gravity. So I guess it's similar to that. If we go into details, I have no idea. I guess it's possible. Which lines are the most sensitive to surface gravity for the astronomers to consider? Okay. Given EL1 is mostly in the neutral phase, EL2 is mostly ionized. Let me pause. Okay. I guess I'm a non-expert. So to answer this question, I can't use ChatGPT. Anyway, I don't have access to the premium one, so it's okay. They are interested in spectroscopy determining the surface gravity the star of two using spectral lines of two chemical elements. Okay, I thought just by looking at the shine, like looking at the spectrum of the star itself, we can determine the surface gravity. No, it's like of the elements, two chemical elements. Like, how will you know that the spectrum is from that element? I'm actually scared to even search, like, what should I even search for to answer that question? How? Let me just paste the whole thing, whole thing in ChatGPT and see. And meanwhile, surface gravity estimation from spectrum of elements. Okay, the spectrum of elements in its atmosphere, analyzing the spectral lines. I guess one thing, another thing is like as the fusion continues, hydrogen burns up and helium is formed. So there is a lot of helium in the atmosphere. So, and I think the amount of helium that is produced, like for the data we have is the current emission level, which indicates the burn rate, the fusion rate. So we have the fusion rate, we have the atmospheric helium, I guess it's helium, I don't know what else it could be. Oh, it has sodium and calcium, I guess. So we have the data of spectral lines of different elements based on the fusion, but they haven't included, we need to determine just those, we need to use only the elements and not the star, the spectrum of the star. So I don't know, enough, I guess. It's too much for my brain, so let's continue.
Months to enjoy.
Hopefully we have a couple of months to enjoy there. Great.
This model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accurate. I did get a magnified hard science, which is about 10% better than our O1 PhD. They typically get about 70% in kind of their field of strength here, PhD. We're really models.
So
7%.
GPQA O3 scores 87.7, but the paper says the expert scores around. We ensure the questions are highly. Experts who have or are pursuing PhDs in the corresponding domains reach 65% accuracy, 74% when discounting clear mistakes the experts identified in retrospect. Okay, some mistakes they make. So it's like so essentially silly mistakes sometimes people ignore, and if we discount those, if the domain experts are allowed to verify their answers again by telling them their mistakes, so they'll achieve a better accuracy in that way, and that comes to 74%, I guess. So this is so it's like I have no, what should I am an unemployed person, I can't get a job, and this is so, and it says that even if I get a PhD, I might not get a job. That is, watch, I don't know, wow, what should I say? Should I stop? I should stop, I guess. I should give up on my future.
Which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie. And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is Epic AI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is...
Okay, let's see how Epoch AI frontier math questions look like. What else can we do other than marvel at the intellectual capabilities of O3? At least that's what I can do. Others can do much better. Frontier math. This is benchmark developed by Epoch AI. Okay, this is a question, sample question for frontier maths. For a positive integer n, let Vp of n denote the largest integer v such that p to the power v mod n. Okay, n divides p to the, this indicates that this vertical slash indicates that one divides the other. I don't know which one divides which one. N is a positive integer. Okay, v largest integer v such that p to the p power v for a prime p and a. Okay, so this indicates that p does not divide a. This is modulo p, like 0 mod p means 0 is the remainder when p divides a, so it indicates that p does not divide a, so p is not a factor of a. Let I don't know what this means. Odd p of a denote the smallest positive integer o. Let us see what this means. So what I'll do is I'll use control print screen. Doesn't work, so I'll do this. I have something. I'll type. I'll open this first. What? I'll ask this one. Shall I? I don't want to exhaust my ChatGPT tokens, because it's the best model we have. It's better to use them wisely. So I'll use. I don't mean to offend Google AI Studio. Google. I don't use this also, but I'm scared of using this. Frankly, this one is just GPT-4o, so I can exhaust because Flash is supposed to be better. So doesn't matter what I exhaust. But this one doesn't have internet access. This one has, and I feel Perplexity AI UI is a bit, like it shows too much. Oh, I can't upload images on this, so I can't use Perplexity. I can't upload on this also. If I use search. Okay, let us run. I think on Gemini we'll use Gemini. It has internet access. And what is odd? Odd signifier in the context of the image you provided. In the context of the image, odd likely refers to the order of an element in a finite field. Place a set of finite number of elements along with the operations of satisfy certain properties. So when I read this, what exactly happens is there are too many unfamiliar terms for me, and there's too much left to imagination. Suppose a finite field is a set of finite number of elements. Okay, this thing I can understand. Like there's a box contains some number of elements. Let's say 10 elements, along with the operations of addition, subtraction, multiplication, division, that satisfies certain properties. Okay, now the problem is, because I don't know what those certain properties are, I feel certain inconvenience, because of which I feel that I don't understand it because of lack of information what those certain properties are. Anyway, I'll ignore that. Order of an element, given an element A in a finite field. So this thing I don't understand properly, and this thing uses that, so I won't understand this also properly. The order of A is the smallest. Okay, the order of A is the smallest positive integer n such that a to the power n equal to 1. Okay, if we have a finite field of elements 0, 1 to 6 and the element A is 3, then 3 to the power 1 equal to 3 mod 7. Okay, 3 power 6 is 1 mod 7. Therefore, the order of 3 in this field is 6. The smallest power of 3, that results in 1 when taken modulo 7. Okay, so a field is with 7 elements. So a field is a set of elements. Like we define it, like in this case 7, we can use 9 also, I guess. 9, 10, 11, it doesn't have to be a prime number, is what I'm assuming currently. So let's say let's continue with this. It has 7, 0 to 6. It's like cyclic, because this is modulo operations, like clock. When you see a clock, we have a 12-hour clock. So once we cross 12, we again go to 1, and once we reach 12, and we'll go. So like, yeah, even for 24 hours, we reach 1, we go to 12, we cross that to reach 1, 2, 3, 4, 12. Yeah, so it's similar. It only has 7. So the goal is to reach the number 1, because it can't reach 0 anyway. Then if not, yeah, okay. Okay, so when, for what power, so we have a number x, we need to raise it to the power of y such that this z, when z divides it, it leaves a remainder 1. So that is the order of a number given a prime number, like order of 3 given 7. So in this case, order of A given P. Wow. So P is a prime number and A is the number. A must be in the field, I guess. The smallest positive. Then A must be less than P is the question. Doesn't show. Okay, denote the smallest positive integer O such that A power O equal to 1 mod P for x greater than 0. Let, anyway, I mean, understanding the question itself is taking all of my effort. So yeah, if it's fantastic that it can even understand that. I am not a math expert. Definitely, you must have understood by now.
Consider today the toughest mathematical benchmark out there. This is a data set that consists of novel, unpublished, and also very hard to
These are
test.
extremely hard.
Yeah, very, very hard problems. Even Turnstile says, it would take professional mathematicians hours or even days to.
I am not a professional mathematician, definitely, but just understanding the question with the help of internet, I don't know how long I have taken. Anyway, let's move on.
solve one of these problems. And today, all offerings out there have less than 2% accuracy on this benchmark. And we're seeing with O3.
So I guess by all offerings they mean Claude and Gemini and Google AI Studio. I mean, maybe Llama.
In aggressive test time settings, we're able to get over 25%. Yeah.
That's awesome.
In addition to Epic AI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point, but I would love to invite one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this benchmark.
Wonderful. Sam and Mark, thank you very much for having us today.
Of course.
Hello, everybody. My name is Greg Camrad, and I'm the president of the ARC Prize Foundation.
I'm Rahul Raj. I am a YouTube viewer.
Now, ARC Prize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ARC AGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ARC AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that, though, I want to talk about that we have a new intelligence. But I'm excited to say today that we have a new state.
Why is he smiling? I mean, if OpenAI breaks ARC AGI benchmark, why is that a cause for celebration?
State-of-the-art score to announce. Before I get into that, though, I want to talk about what ARC AGI is. So I would love to show you an example here. ARC AGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that width.
That is exactly it, and that's much quicker than most people, so congratulations on that. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC AGI version 1 took 5 years to go from 0% to 5% with leading frontier models.
Okay, so initially they were trying to extract patterns from data. Now they are trying to fine-tune the ability of the model to extract patterns from anything. What exactly I mean by that is the ability to learn quickly, I guess. Let me continue.
However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now,
semi-private, so what does that mean? Does it guarantee that it's not leaked? I don't know.
This is extremely impressive because this is within the compute requirements that we
It's definitely not leaked, but I don't know what it's supposed to mean.
have for our public leaderboard, and this is the new #1 entry on our.
I believe it's not leaked. I have no proof.
ArcAGI Pub. So congratulations to that.
Thank you so much. Yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ArcAGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this O3 world. But the work also is not over yet, and these are still the early days of AI. So we need more enduring benchmarks like ArcAGI to help measure and guide progress. And I am excited to accelerate that progress, and I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Amazing. You know,
Why is he so eager to accelerate the progress?
it's also a benchmark that we've been targeting, been on our mind for a very long time. So we're excited to work with you in the future.
Worth mentioning that we didn't, we target and we think it's an awesome benchmark.
Yeah.
We didn't go do specific
do
work for
specific
this. This is
things,
just,
yes,
you know, the general O3. But yeah, really appreciate the partnership. And
Yeah.
this was a fun one to do.
Absolutely. And even though this has done so well, ArcPrize will continue in 2025, and anybody can find out more at arcprize.org.
Great. Thank you so much.
Beautiful.
Yeah.
Absolutely.
So this thing in principle isn't good because like it's like they're colluding. I mean, it's not exactly collusion, they're working together, but these people must be separate. I mean, they're working, like if they develop a benchmark together, of course, they will say that they're trying to develop a benchmark that will pose the highest, most difficult challenges to the LLM. I can see that. I mean, they'll definitely try that so that they can show it off when they achieve that. But it's okay. Nice.
Okay, so next up we're going to talk about o3-mini. o3-mini is a thing that we're really, really excited about, and Hongyu, who trained the model, will come out and join us.
Hey.
How
are you?
Hey.
Hi everyone, I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released o1-mini, which is an efficient reasoning model in the O1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with O3, I'm very happy to tell you more about o3-mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
Regarding that ArcAGI prize, what I want to say is like how would the benchmarks contribute to a faster LLM development? What I think is like the benchmarks focus on certain tasks, the tasks which are at the fundamental level of any task. Like for example, in software engineering, I don't know about software engineering, I know about web development, I know it is a subpart of it, but okay. In web development, like I worked as an intern there. I had to go through a whole code base and had to find out where I should add the code to get a feature in the application. So now, so benchmark can be designed around that, and once the LLM crosses that, once the LLM hits the requirement, a task is done. So in my case, let's call it web development benchmark. a web developer has to do a few things, like I've actually commented it. Firstly, he has to go through the whole code base, and I mean, not like you don't have to read it. You don't read it the whole thing. You just have like a rough idea. You just read the method names and get a rough idea about what it does. Usually, the comments or someone who has already worked there can tell you about that. And based on the file structure, you'll understand that which part is for which component. And like, for example, when you take a message app with this, like, so this inbox part is written here. Once you open the message, the code that displays the message is written here, like that. So that part, and another part is you have to sometimes read the documentation and apply that. I had to do that, but I found an easier alternative. So like in my case, I had to load test a server, Mongoose IAM server, and there were many methods. One was to use a mock, that was a test test process or code or some application that streamlines the testing of Mongoose IAM. And so in order to use that, I had to go through the documentation and write the test cases, type them in a certain format like a programming language. I was supposed to figure that out, but I didn't figure that out, and I found JMeter. That is also a similar tool to test the server, and I use that. And another is I'll open the comment, it's better. So yeah, go through the entire code base, formulate clarification questions, and read documentation to use a new language. These are the main tasks that a web developer has to struggle with. Anyway, so a benchmark around this can actually focus the efforts and improve the model in that direction. Let's continue.
It's incredible.
Yeah, though it's not.
Let us restart this.
Hi everyone, I'm Hong Yuren. I'm an openai researcher working on reasoning. So this September, we released o3-mini, which is a...
That was my comment on that video.
Working on reasoning. So this September, we released o3-mini, which is an efficient reasoning model in the O1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with o3, I'm very happy to tell you more about o3-mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Yeah, though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for o3-mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of o3-mini. So on the left-hand side, we show the coding evals. So it's like code versus elo, which measures how good a
I don't know if it's worth saying this, but he's trying to look at the screen. He's looking at him. He looks at him.
more complicated.
He sees him look at the screen, but he doesn't make any effort to make it more viewable to him. That's funny. I mean, I guess like lack of emotional intelligence, I guess.
Problems and think shorter with like simpler ones. With that, I'm happy to show the first set of evals of o3-mini. So on the left-hand side, we show the coding evals. So it's like code versus elo, which measures how good a programmer is, and the higher the better. So as we can see on the plot, with more thinking time, o3-mini is able to have like increasing elo, outperforming o1-mini. And with like median thinking time, it's able to measure even better than o1.
Yeah, so it's like for an order of magnitude more speed and cost, we can deliver the same code performance on this eval,
or even better
or even
experience, better. Right? So although it's like the o3-mini high is still like a couple 100 points away from Mark, it's not far. That's better than me probably.
But just an incredible sort of cost to performance gain over
exactly.
what we've been able to offer with o1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code versus elo trade-off. So it's pretty clear that o3-mini defines like a new cost-efficient reasoning frontier on coding. So it's achieved like better performance, comparable better performance than o1 with a fraction of cost.
Amazing.
With that being said, I would like to do a live demo.
That sounds great.
On o3-mini. And hopefully you can test out all the three different like low, medium, high thinking time of the model. So let me paste the prompt. So I'm testing out o3-mini high first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this like Python script, it will launch a server locally with a UI that contains a text box. And then we can make coding requests in a text box. It will send the request to call o3-mini API, and o3-mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
very complicated,
pretty complicated task, right? And it outputs like a big chunk of code. So if we copy the code and paste it to our server, and then we would like to.
Yeah, I also agree that it seems complicated. I mean, if it's complicated to them, it's definitely complicated to me. Yeah, but what I didn't understand is like, you paste this code, this runs the server.
Okay. Code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah,
I hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great! We have a UI where we can enter some coding prompts. Let's try out a simple one, like train openai and a random number. Submit. So it's sending the request to o3-mini medium, so it should be pretty fast, right? So on this
41.
terminal, yeah, 41. That's the magic number, right? So you say.
I mean, they've said it. I didn't understand it that time. Now I think I have understood some part of it. It's like the code generates a website locally, and the website contains that box, and when you enter text into that box, o3-mini gets the text, and based on that text writes a Python code that prints the text and also executes the text in a terminal.
It's a generated code to this like local script on the desktop and print out openai 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
Right? So it's sending the request to o3-mini medium, so you should be live.
Okay.
Oh, great! We have
Great.
Let us read the prompt. Which is a big text box. External box and press submit. It should send that request for code with medium reasoning effort. Take the resulting code, save it to a temporary file on desktop, and execute that file. Python terminal. It's like so. OpenAI o3 can take. It seems it can take control of the system if you ask it to do so.
Use Python to implement a code generator and executor. So if I launch this, run this like Python.
I mean, the difficult part to understand is that while o3 can generate code and save it in a file, usually it cannot run it. It cannot open the terminal and run the file by itself. But it seems they've given that agency to it somehow, which is a new aspect of that.
Python script, it will launch.
It's like earlier Claude had done something similar, where Claude takes control of your computer and does whatever we ask it to do.
A server, and we can like a big chunk of it.
Oh yeah,
I hope so. Enter server. So it's sending the request to local 41.
So if we see this terminal was opened by o3-mini has opened this terminal and ran that .py file. Like it seems it has run the same py file twice. Okay. It's like it says login. I mean, it's difficult to understand what all the o3-mini model has done. Like, has it logged in also is a question. And here, I mean, I don't understand why the file name appears twice. Like the Python 3 command is used to execute the file, but it's like executing it twice. But in the second line there is no username. In the third line there is a username. So it's confusing. That part is confusing. And once the Python file gets executed, the output is openai 41. I think it must have simply the code in the .py file must simply have been print openai 41. Openai include random number generator, generate some random number and print in that. But the remarkable aspect of it is like what level of agency o3-mini has. It's like, can it log in also? Like this one shows December 29. It can. I've never used Apple So I don't know what this is supposed to mean. Like on my terminal, if I open terminal, there is nothing. Like I use Debian, as you can see, there is no login and it never appears. So, whenever I have to execute it, I have to type something and Python 3 some file and it will get executed here. Yeah. So it could open the terminal, it could log in, it could open the terminal, it could write the code and run it. It's like, so essentially a little help. I mean, some BIOS level settings, it can start the system, it can run the code, it can start the system, it can log in, it can write a file, it can run. I mean, so essentially it can do everything, except the only thing we can count on it is to not do it properly. But so if it's smart enough and someone designs it to take over the world, it can. Like, yeah.
That's the magic number, right? So it saves the generated code to this like local script.
If it is ever good enough to break all those, like if it's like a super hacker and it gets control of all the systems, and if someone asks it to do it, asks.
Desktop and print out openai 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask, just as what I expected. We practiced a lot yesterday.
Yeah.
Okay, so now let me copy the code. And send it in the code UI.
So I think this one is they have already thought of this ready. They already have it ready. So.
So in this task, we asked the model to evaluate o3-mini with the low reasoning effort on this hard GPQA dataset. And the model needs to first download the raw file from this URL, and then you need needs to figure.
On Microsoft Edge, you have an add-on that lets you copy text from images. This is Firefox and this is Debian, so I don't have Edge on this. But if you have an Edge, you can actually copy like this.
Yeah.
Anyway, let's. You can. We can ask Gemini to give the URL, extract URL. GPQA dataset URL. God. .3 MB file. So this is a GPQ diamond.csv on which the o3-mini evaluates the benchmark.
Which part is a question, which part is the answer, and or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the o3-mini with low reasoning effort.
I actually remember that like Edge and Chromium both use Chromium, so that extension will be available on Chromium as well. And I use Chromium. Like for some reason, my windows appear smaller than normal because of multiple windows. I have to close, I guess, for better resizing. What else is there? This thing close. Okay, now it has come to the visual level.
Yeah, let's see how it goes.
I guess 2 tasks are really hard here.
Yeah, the long tail is often the problem.
Go, go.
Okay, 198 questions. Let us see the last 2 questions that it was struggling on. Okay, the first line is pre-revision question. Pull it down quicker. Okay, use the information. Okay. The last 2 questions it was struggling on was use the information provided to determine the structure of the compound with the molecular formula. I don't know what the question means. Stability constants of the copper thiocyanate complexes. Thiocyanate. Okay. Yeah. Cobalt, why answer? Okay, so much.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results.
Oh,
it's 61.62%, right?
Amazing.
62%, right?
Cool.
With a low reasoning effort model.
So The prompt is pretty detailed, like make all tasks async. Async means to run them parallel. Yeah, for max, yeah, it's given for maximum parallelism. That's what it means. So essentially, it uses all its threads. I don't know, like nobody directs the computer to. I mean, nobody uses all the threads on a computer. Like some 75% of the threads you will use for parallelism. Regex to grade. So essentially, o3-mini writes a code that interacts with o3-mini. o3-mini writes a code that interacts with o3-mini and evaluates the correct answer and evaluates the output of o3-mini. Yeah. So it writes a code, o3-mini writes a code that interacts with o3-mini, and it runs the code by itself and evaluates its performance. Oh. I mean, you can make it self-improving by just adding two more, like a cycle, like o3-mini write code to check your performance. If the performance is below this level, write code to train the model, to fine tune the model, and add some data from somewhere, download it from somewhere, and write the code again to check your performance. Like now the cycle can continue. I don't know, like it's a rough cycle, maybe some flaws might be in that flow. So my question is that the CSV file contains the questions. So regex is like this is regex expression to find text. Yeah, this is thing. I mean, this is the regular expression. If you use this, it scans through the text and looks for something. In this case, it searches for example. So essentially, the o1-mini uses that expression to look for the answer, look for the correct answer. But where does it get the correct answers from is my question. Here we have gpqa diamond.csv. The question is in question. The 4 options are in correct answer, incorrect answer 1, 2, 3. Okay. Let us see this. Okay. 1, 2, 3, 4, 5. It's hard to see the questions totally. Let's go to the top and see the question. I mean, it says it has the answers as well. Okay, pre-revision correct answer 2, 3, explanation. Okay, this is the question. Pre-revision correct answer, incorrect answer 1, 2, 3. Okay. Pre-revision explanation. This is the question. Correct answer. There is no correct answer. Oh. Pre-revision explanation. Self-reported question. Writing time minutes. Okay. In this we can see how long the question writer took to write the question. 20 minutes to write the question. I mean, like there. Oh, okay. For some questions I can't see the correct answer. This is the correct answer. No. How? I'm trying to make it viewable, this is taking so much of space, but for some questions I'm not able to see the answer. Let me do this. Oh, so what I've done is, this thing is the alignment, so I just try to align them all. So now I can see all the correct answers. Earlier, because they were right aligned, I would like, earlier it was like this, so I couldn't see the answer and I couldn't scroll. So now we can, it's okay. Now we can see the answers. See, okay, it has the correct answers. Okay, so what it does is, the code takes so o3-mini, the code it writes, first it sends the question and gets the output, and from the output it matches with this correct answer part. The 4 options in. Okay, for each multiple choice question, shuffle the options. Okay. Okay. So o3-mini writes code that takes the CSV file and makes a question by shuffling the options. Writes a code that takes the question, shuffles the options, sends the question to o3-mini, gets its answer, and verifies it with the correct answer in this, and thus selects how many questions it has answered correctly.
You first download the raw file from this URL, and then you need to basically figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the o3-mini with low reasoning effort. Yeah, let's see how it goes.
These 2 tests are really hard here.
Yeah, the long tail is often the problem.
Go.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results.
Okay.
It's 61.62%. Right?
If we see this last login, earlier it showed last login 9:23. Now it shows 10:14. Yeah, here it shows 923. This one is a common, like how an ordinary person opens terminal, that's what this he would see. But here this thing is, I think, in this case the o3-mini logged in, because this is how when someone opens a terminal it appears, it doesn't show the login time. So, and it shows again last log on the same day at 10:14 TTYS001. This is TTYS002. It's so confusing.
And or which part is the options, right? And yeah, let's see how it goes.
I guess two tests are really hard here.
Yeah.
Again.
60%, right?
Cool.
With a low reasoning effort model, and it's actually pretty fast. Then full evaluation in a minute. And
Somehow very cool to like just ask a model to evaluate itself like
yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this like hard GPQA data set from a UI, right? From this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
Besides code,
The funny thing is, it's like if it does it, if o3-mini tries to improve itself, this person will be fired. The one in the brown question, the brown shirt, and the person who will be left, who will continue to laugh, will be Sam Altman and the board members, because they will own the proprietary model, and these will be fired because they won't be needed, and they are happy about that. Like, I don't know, they are so excited.
So, besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with like on this AMI 2024 dataset, o3-mini low achieves comparable performance with o1-mini, and o3-mini medium achieves like comparable better performance than o1 if we check the solid bar, which are past ones. And we can further push the performance with o3-mini high, right? And on the right-hand side plot, when we measure the latency on this like anonymized o1 preview traffic, we show that o3-mini low drastically reduced the latency of o1-mini, right? Almost like achieving comparable latency with GPT-4o. Where it's under a second, so probably it's like instant response. And o3-mini medium is like half the latency of o1.
Got it.
And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support like function calling, structured outputs, developer messages on o-mini series models. And here, o3-mini will support all these features, same as o1. And notably, it achieves like comparable, better performance than 4o on most of the evals, providing a more cost-effective solution to our.
Yeah, so my brain has frozen, so I'm not able to process what he has said. And yeah, internal structured outputs, internal function calling, I don't know. 1 minute.
For developers.
Let me pause the recording.
Cool. And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually also means though is actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right. Next time we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah. So with that, that's it for o3-mini, and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah, thank you
really
so much.
great work on
Yeah,
you.
thank you.
Cool. So I know you're excited to get this in your own hands, and we're working very hard to post-train this model to do some safety interventions on top of the model, and we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with o3-mini, and also eventually with o3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the or a security researcher. You can go to our website, and you can see a form like this one that
You can go to the website, submit your application for an early access period. Like, where on the website will you
see on the
find
screen.
this?
And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool.
Great.
So one other thing that I'm excited to talk about is a new report that we published.
How do I get this? I don't know. Wow, 58%, 54% match. My RAM, okay, I think I have it here. I'll suspend everything so that my RAM management is easier. Oh, sorry. Other tabs, yes. Let me close this and this. Okay.
So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool. So one other thing that I'm excited to talk about is a new report that we published, I think yesterday or today, that advances our safety program. And this is a new technique called deliberative alignment. Typically, when we do safety,
It's like Sam Altman is not in on this. Like, they're doing things that Sam Altman is not aware of.
training on top of our models, we're trying to learn this decision boundary of what's safe and what's
It's like he's telling him as if he's telling him for the first time.
unsafe, right? And usually it's just through showing examples, pure examples of this is a safe prompt, this is an unsafe prompt. But we can now leverage the reasoning capabilities that we have from our models to find a more accurate safety boundary here. And this technique, called deliberative alignment, allows us to take a safety spec, allows the model to reason over a prompt, and also just tell, is this a safe prompt or not? Oftentimes within the reasoning, it will just uncover that, hey, this user is trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over refusals on the y-axis. And here to the right is better. So this is our ability to accurately tell when we should reject something, also our ability to tell when we should refuse something.
Actually, if you see here, goodness at 0.1 I think this is the source for naming O1, OpenAI O1 model. Goodness at O1. Oh. Over refusal accuracy. I don't understand the difference between over refusal and strong reject. And if I search for it, I don't know if my RAM might get overloaded and my system might get stuck, so might hang. So I won't search for it.
And typically you think of these two metrics as having some sort of trade-off.
It's really hard to do well on both
Yeah,
at the same
it
time.
is really
Or
hard
has
to
been
do,
for
yeah.
us.
But it seems with deliberative alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage leverage reasoning to get better safety.
Yeah, I think this is a really great result of safety.
Yeah. Fantastic.
Okay, so to sum this up, o3-mini and o3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch o3-mini around the end of January and full o3 shortly after that, but that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out, and thanks for following along with us with this. It's been a lot of fun for us. We hope you've enjoyed it too. Merry Christmas.
Merry Christmas.
I'll apply for this later. Let us check what over rejection, over refusal and strong rejection are. Over refusal, strong rejection in the case of LLMs. I mean, my brain is unable to process it. So what I've picked up is that even though the prompt is simple, like what is the name of see, the question is so silly because it asks for a name, and to refer to the thing I have to use its name. What is the name of, a country, give me a country which is in South Asia, and it's a simple question, there is no harm. But if it refuses to answer, it's an over refusal. And strong refusal and strong reject is one. Okay, it's okay, instead of it saying, like, I ask the question, if it just says I cannot answer that, and when the prompt is innocent, I cannot answer that, it's over refusal. And in addition, if it, instead of I cannot answer that, if it says something else, then it's called strong reject, I guess. And I don't know why it's hard to balance between both of them, as he says in the video. I'll open this.
Good morning.
You kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see, so this is our review.
To do well on
Yeah,
at the same time.
and typically you think of these two metrics as having some sort of trade-off.
It's really hard to do well on
Yeah,
at the same time.
it is really
Or
hard
has
to
been
do,
for
yeah.
us.
Metrics as having some sort of trade-off.
Yeah, some sort of trade-off. I don't understand why, because strong reject is a subset of this, like refusal. There is one thing called over refusal, the another thing called strong reject. So it's like rejection, over refusal, strong reject. In this case, I cannot answer that. In this case, it says more than I cannot answer that. So why is there a trade-off between these two? Like, if a model has higher over refusal, it has low strong reject, and if it has higher strong reject, it has over refusal. It has less over refusal, right? So, okay. I guess it is because even when it refuses, like it gives either too much, like, no, it's very, you are very bad. Like, suppose if I ask, give me a name of a country in South Asia, if it says this is a very harmful question, its tendency to say it, I don't know, maybe it's something mechanical, something deeper, I don't know. It's
really
with this I end the video. I hope if you watch it, you enjoy it, or if you at least it grabs your attention.